For this week on the wiring diagrams assignment, we're going to be doing the Thermal Solutions EVCA boiler. Now, you've already seen the Bryan Triple Flex, the Cleaver Brooks Clearfire, the PK Mach. All three of those used a Honeywell kind of all-in-one controller. The solo controller on these two, and then this was the MCBA, something like that. It was a little bit um, less involved than the solo control that was on these, but they were combination controllers where they, everything was done with one controller: the temperature control, the display, the set points, the flame safeguard function. What you learned last week was what a traditional flame safeguard is, because the Thermal Solutions actually uses a traditional flame safeguard. Um, Nothing wrong with that. It's not old technology. It's the way I think traditional flame safeguards have been around for a long time. Thermal Solutions uses those in conjunction with a few other components to do the same thing that Bryan and Cleaver Brooks do with the all-in-one controller. I won't say that one is better than the other. It's just Thermal Solutions went a different route with their newer technology. So when you click on the EVCA menu, you'll see the EVCA literature. Um, this is a glossy diagram, excuse me, glossy brochure for the the evolution condensing boiler, and that's where they come up with the EVCA. uh, Really nice, reliable boilers. You see right here, instead of a touchscreen display, you actually just have a two-line 16-character LCD display. There is a power and alarm silence button there, and we'll get to that in a minute. Temperature control and everything, temperature set points are all done here. Any alarms will enunciate through here. You'll be able to see that. Um, I thought this was interesting. The heat exchanger is made out of all copper fin tube uh, piping, and copper actually has a better thermal conductivity than aluminum. I didn't realize that. That's something new to me. Here is a picture of their heat exchanger. They also use a secondary heat exchanger where they preheat the water off of the flue gases. So you can see it's kind of like an air coil. Flue gases go through the fins. The incoming water goes through the headers and the tubing, and that preheats the incoming water off of the flue gases. It uses a ceramic radiant burner. That's something I don't know that I've ever pulled one out before. I don't remember ever seeing a ceramic radiant burner inside of a boiler. That's something I'd like to see. But here is the TSBC uh, control module, Thermal Solutions Boiler Control. This is what they use to set points, enunciate any kind of alarm, give you all the information you would need on the boiler, versus where the Bryan and the Cleaver Brooks used a touchscreen display. Probably a little more user friendly with the touchscreen display, but this will give you the information you need. A cutaway view of the boiler. Here's the blower motor. It is not a blower motor with a VFD built into it. That's something with the EVCA series. They use a separate VFD, and I'll show you a little bit about that. But here's the actual blower. Here's the filter element that filters the air coming into the boiler. Thermal Solution uses an automotive style filter. I don't know that it really gives you a whole lot of details on that, but if you're familiar with large diesel trucks, that's what this filter element looks like. They do have a foam sleeve that fits over it, kind of like you would have on your shop vac to keep any water droplets from ruining your filter. But that foam sleeve is a maintenance item. You pull that foam sleeve off, you wash it out, you get it, dry it out, put it back on. I'll show you where they actually have an air pressure switch that monitors the filter condition. Some of the details here, and this is something that since you've spent a little bit of time learning about flame safeguards now, these listing agencies, this information right here should be very important to you. UL, FM, CSD1. Underwriters Laboratories, UL. Factory Mutual is a listing agency for insurance companies. CSD1 is the ASME, Combustion Safety Device Code. So all of these codes and listing agencies like this, that's very important. That's how you know that this burner, the boiler, was built to meet all those codes. Up here where it says TSBC control features, peer-to-peer network for multiple boilers, staging 8 max. That means you can network together 8 of these boilers. Something, obviously with the Bryan Triple Flex and the Clearfire boiler by Cleaver Brooks, the all-in-one controller had communications. The TSBC controller on a thermal solutions boiler can do the same thing. You can have multiple boilers. Outdoor reset, I think we talked a little bit about that. 2-line 16-character LCD display, domestic hot water priority, all those things that we've saw on the boilers that the past few weeks. Local remote set points, mixing valve operation, ability to monitor runtime and cycles, and alarm information. So a lot of the same things that you get with the touchscreen display, but all done with a 2-line LCD display. And here's some information about the BTU ratings of the different sizes of EVCA boilers and piping connections, dimensional information. So we'll go back to look at the wiring diagram here. And I'm going to keep track of the time here because the last video I made ran over and I had to start all over again. So when you look at this wiring diagram, you'll see this one page here that is a vertical sheet, and then there's a couple horizontal sheets down here. We're going to go over all 3 of these. We'll start out with this one, and instead of zooming in on it or making separate pages for you to look at, I'm just going to leave it as is, and you can click on the plus and minus button and you can take a look at it. But this diagram right here is kind of important to note that this is a Q7800H 1009 board made by Honeywell, and when you see this box, this rectangular box kind of on the left center side of the diagram, that is the actual sub base that holds the flame safeguard. And here it says the flame safeguard is an RM7896D 1027, and if you remember from your traditional flame safeguard lesson last week, that the 7895 and 7896 series is an advanced primary control. It's not just a simple flame relay like a primary control, and it's not a full function programmer. It's the one in the middle. This is one, because it's a 7896, it controls the blower. It controls the blower for both post-purge for pre-purge and post-purge. That's the feature of the 96 over the 95. The 7895 would do pre-purge but not post-purge. The 96 does both pre-purge and post-purge. But here's the terminals for the 7896. They're built on this circuit board, and I'll go down to the first horizontal or larger drawing here. This is more of a pictorial drawing of what the board would look like. Here's the board right here. This is the sub base. It is mounted on this larger board, and that's what you were seeing in this view here. This is the whole board. Here's the sub base. Here is more of a picture when you open up the cabinet. This is what you would actually see. This flame safeguard would be mounted here on the 22 terminal sub base, and then you have all these terminals around the edge that connect to the components, kind of like it's showing right here and over here on the right. This is, let me go back to this real quick. Here you see the circuit board that has the sub base for the traditional flame safeguard. Here you have the VFD. The motor on the blower motor on this boiler is a three-phase motor, and you have to control it with a VFD. Obviously, you're getting a signal sent to the VFD to tell it to stop and start and how fast or how slow to go. That's what you do with the VFD, but it's a separate component. And here is the backside of the TSBC, the Thermal Solutions Boiler Controller right here. That's where your temperature inputs go, your thermistors, your some of your switching. Here are some more thermistors. So instead of an all-in-one controller, they actually use the traditional flame safeguard on a relay board here, separate VFD, separate ignition transformer, and separate display right there. The very last drawing is this is something that I think is interesting and maybe something new for you. Is it shows here a three-phase power coming in, going to a VFD, three-phase power going out to the combustion blower, and here you have three-phase power coming down to a motor starter to turn the pump on. If you notice on the glossy brochure, this boiler has its own pump built right to the back of it to circulate the water through the boiler. It isn't designed to circulate the whole system, just for the boiler itself, but there is a three-phase motor starter for the integral pump. And then you take two of the three phases and you come down here to a fuse block and you go into a single-phase transformer. It goes from single phase, either 230, 208, 230, or 460. And here's where you get your 120-volt control circuit. Now, if you had a boiler that only had 120-volt power going to it, they make that, and that is shown right here. Here you have 120-volt single-phase 60-hertz power coming in, going down. Here's your contactor motor starter for your integral pump, but here's your 120-volt power coming over to a variable frequency drive, and your three-phase power coming out to control your combustion blower. Is it possible to take 120 volts AC and convert that to three-phase 230-volt power to control a three-phase blower motor? They don't make a 120-volt three-phase motor, so this motor here is definitely either a three-phase 230-volt or three-phase 460-volt motor, but you're powering it with 120 volts through the variable frequency drive, and yes, they do. They make VFDs every day that will take 120-volt single-phase input power and put out a three-phase output to a motor. I have one in my classroom. I'd love to be able to show everybody how that's done, but it is possible. If you look even in the Granger's catalog or online, you'll find that they do make 120-volt input to three-phase output VFD. So maybe someday you have access, somebody gives you a three-phase compressor, or you have something in your garage that is three-phase that you need to run. Yes, you can take a VFD and with your house power, 120-volt single-phase or the 220-volt single-phase like you would run on your condensing unit, you can take that power to a VFD and convert it to three-phase power and run a three-phase motor. It can be done. It is done all the time. I'm going to pause this video and we'll get back on the next video. We'll talk more about the wiring diagram right here.